In this video, I'm going to look at using Wolfram Cloud to fit some data to an exponential. And I'm going to, at the beginning, show sort of a couple of different ways to sort of get the data in. So the first way is just to straight up type it. So these are sort of, this data is about radioactive iodine, sort of decaying as a function of time. So these are sort of XY pairs, and the X is a time, an amount of minutes. And then the second is this rate, sort of how many counts per second. So we see as time goes on, this Y, the counts per second, going down. And so you can just sort of type in the pairs, and then you have like, call it the set of pairs. And so that's just typing. And I'll do a shift enter, and that's the data, and I call that iodine 1. Now I have at this, the URL you see here, I have a CSV file. A CSV file will look like this, just the data, the XY pairs, sort of the time rate pairs going down, just typed in a simple text file separated by commas. And all I have to do with the CSV is announce that it had the units were in a particular first row. And so Mathematica has this thing, Wolfram Cloud Mathematica has this thing called HeaderLines. And you just say that first row, that's a header line. I don't want it. It's not data. And for plotting, it doesn't matter. You can forget that. But for later, we're going to fit it. And if you have something that's not numerical and you're trying to fit it, it's going to go a little crazy. So, and let me just show you how to get this last thing in case you're new to Mathematica. You type in what you want, header lines, and then you sort of make an arrow, which it turns into an arrow. Okay. And so then that is sort of version 2 of reading in the data, getting it from a file. I can, if I were on Mathematica, sort of on the local computer, I could also use like the path on the computer. But I'm up in the cloud, so I'm going to use data that's also sort of on the internet. Okay, so that was version 2 of Iodine 2, reading a CSV and designating that I want to ignore the first row in terms of data. You can also do fancier things, bring in the headers to see what they are and then ignore them later. And I'll do something more like that with my Excel version. So I also have the data in an Excel format, pretty similar to the CSV, except there's more to Excel. But there we go, that's the Excel. And I have it at this location, so you can import that. And right now I'm just sort of bringing in the whole Excel. So there are ways I can designate what I want to bring in from Excel, but I'm not doing that here. I'm just sort of saying, bring in all of Excel, and then I'll deal with it over here in Wolfram. And so I called what I brought in Iodine 3, and now you see the previous ones were sort of a double curly. There's a set of curlies and then curlies within, and Iodine 2 was the same. But now what I brought in from Excel has sort of triple curlies. So Excel has sheets, even though this one only had one sheet. In principle, Excel can have multiple sheets. So I think that is a sheet thing. So I want to pull out, I'm going to sort of slice out what I want from Iodine 3 and call it Iodine 4. And and it's this sort of double square bracket notation and these semicolon semicolon notation that they use. So the first, so it's iodine 3, which I read in from Excel. Double square bracket 1 means I'm interested in the first sheet. And then the second set of double square brackets are going to specify what I want. And for what reason did I? No good reason. This should be 2. I want to start, it's sort of the rows and the columns. Let's just find the rows and the columns in Excel that I want in case I had additional things. And I'm also starting in 2 to get rid of the headers here. So start in row 2, and then this is sort of this semicolon semicolon means go up to, and -1 just says go as far as there's data. And then I have a comma, so these are the rows and these are the columns, and I want columns 1 and 2. Let me shift enter that. And there we have it. So now the data is in the same format as the others. And we're ready to go. So here is, now I'm going to list plot iodine. You can do any of them now, they're all in the same format. So let me just switch back to the original iodine 1. So I'm going to plot the data I called iodine 1. I'm going to give it a sort of a title of radioactive iodine, axis labels, the X. This is an XY pair. The X-axis was time in minutes. The Y-axis was rates, which was measured in counts per second. And shift enter. So there is the plot of the data. I'm just going to do one version, but I wanted to show you these different ways of getting the data in. But now all that data, iodine 1, iodine 2, and iodine 4 are all of the same. So I could have done any of them. So there is iodine 1. Let me be consistent, switch this to iodine 1. So now I'm doing a FindFit. So this was, it's a nuclear decay, so not surprisingly, it's an exponential fit. So I'm going to use Wolfram's FindFit. I'm going to fit the data, iodine 1, to the form A times exponential of B times X. And that I could get away. Mathematics is pretty smart. I could get away without these stars, but I'm also used to using other packages that need the more explicit multiplication, so I tend to put it in. But there's the form, and then I'm going to give the parameters sort of some starting place. And I don't have to be that smart, but just some basic. When you exponential decay, the first parameter is where you sort of start. And so I'm saying I'm starting in the ballpark of 400. Now that first number, that 359 was at 4 minutes, so it might be higher than that, but just so I'm in the ballpark, it's good. And for the second parameter, I just want to say it's an exponential decay. So just so long as I made it negative, was enough to have it converge. And then so it gave me these more specific values, 441 and minus 0.028. And I'm just going to put those in to a plot. So I'm just keeping 4 significant places here. So let me do that. Maybe consistent and do 4 for both of them. So now I'm going to plot it. I'm going to give the plot a name. And I gave the list plot a name. I had iode plot, and I gave the my fit a name, fit plot. And then I am going to put them together with show, Plot and fit plot, and add an epilogue of the uh, epilogue is an inset, and I'm just putting in sort of very explicitly by hand the formula. And I could do fancier and get my fit parameters from above, but it is just a quick and dirty. So I just wanted to just typed. And there we have it. So that's what I wanted to show you in this quick example. Some different ways of bringing data in. Just type it yourself if there's not much. Maybe bring in a CSV, maybe bring in an Excel on the cloud. So I'm bringing it from a web source, but I could, if I were working with Mathematica, which is basically the same, but sort of more of a desktop application, then I might also bring it in from a path on my computer. How to deal with multiple sheets of Excel to get down to one cell and pick out the rows and columns you want. And then the idea of the FindFit for the exponential and combining the data and the fit together. So that's all what I wanted to show you. Thanks for your attention.